number of favorable outcomes divided by number of exhaustive outcome. Exhaustive outcome means what? The total outcomes expected from the experiment. If there is any drawback from the first approach, of course we are trying to go for the next approach, which is related to relative frequency approach. Oxim means what? There is statement. If the statement is fulfilled or the condition are satisfied, okay, so based on the statement only we are able to decide. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. We are in the Unit 3, Section 2, third semester BCom, probability distribution. In the last section, I have introduced the theory of probability and a few basic terminology which is related to the probability distributions. Okay, moving forward, my today agenda. So here the 2 dice sample space outcome, because any probability if you are trying to do based on the experiment, whatever I told, there are 2 dice, because I have explained in the last class EPP means what? E stands for experiment. Now which is experiment which is related to dice. So what is a 2 dice total outcome? So we are able to identify. So in this 2 dice samples total outcomes we are finding, that is which is related to dice experiment, and the possibility we are getting 36 when we are rolling 6 into 6, if you multiply 36 result we are expecting. So here the each probability having, so for example the one die if you take 1 by 6, so here the probability chance, then there is one playing cards outcome. If you try to go for experiment which is related to playing cards, what is the total outcomes you are able to identify? With the figures only you can understand much better. So next one, approaches to the probability, because whenever you try to solve the probability, something we are trying to assign the probability, so which is related to, there are 3 types of approach, one by one I will discuss in the moving slides. So here the first my agenda is a 2 dice sample space outcomes. In a random experiment, when you are trying to go for experiment finding the result, we are able to get 36 result here, because one dice is having a 6 space. If you take simultaneously, if you are trying to rolling with the help of 2 dice, we are able to get the result here. So here the first 1, 2, 3, 4, 5, because each dice is having a 6 space, right? And same thing, even one more dice if you try to take, see the first when you rolling, the first dice you are getting which is appear 1 numbers, and the second dice also we are getting 1. So like this the total result will be, this is nothing but your total outcomes we are able to identify. So if you try to go for 1 dice, we are able to get only 6 numbers, but if you try to go for 2 dice, we are able to get the total outcome is 36 here. Now here see, whatever you try to do, the total samples you are writing before solving the problem. So the total samples we are getting here 36. So individually have written, I have explained here, clearly specified. The first die is getting 1, the second die also getting 1. The first die when you rolled you are getting 1, the second die's result will be 2. So like this we are writing the capital letter S is, which is nothing but the total sample space. Okay, so here just for understanding sake only have specified this using a tabular format I have shown here. Moving forward, so the playing card samples, drawing 1 card from the playing cards. So the deck what you're selecting, the playing cards, we have around 52 cards. In the 52 cards we can identify, so based on the image, based on the color, based on the numbers. So this is your total outcome. So when you are writing a samples, the total samples of playing 1 pack of playing cards will be 52. So the total, how it is representing based on the color, there are 2 colors we are able to identify here. One is black and one more is red. Okay, now the 52 cards, so 26 card is which is red belongs to red color, and 26 belongs to black color. Okay, and yes, we are able to identify there are different types of designs we are able to identify. There are 4 types of card design or shade we are able to identify. So here the flower and heart, spade, club, diamond, so everything, the diamond, and club, okay, like this, the different colors we are able to identify. So here the spade, which is related to spade, in the each and every card, each and every design, we are able to get 13 total cards. Okay, so here what do you mean by the face card? Face card is a jack, queen, king is a face card. Okay, and here the spade, what you are able to identify here, this one is your spade. Now club, and one more is a diamond, here diamond, last one is a heart. Okay, like this we are able to get the clarity. Whatever the image is very transparently you can understand. There are different, okay, how many colors we are able to identify? There are two colors, red and black. And how many designs we are able to get here? We are getting an idea. We have 4 designs. One is a spade, club, diamond, art. So like this we are able to get here. Okay, each and every card we are able to identify one spade. King is a face card. Okay, even the queen is a face card, jack is a face card, sometimes the ace will be a face card. So we are able to identify each and every card. 13 numbers we are getting. So you are just want to get a clarity. That's what I am explaining here. Under spade we are able to identify there is one king card, there is one queen card, there is one jack card, there is one ace card. So numbers, okay, so here ace is nothing but your 1, number 1. Now starting from 2 to 10, okay, 2, 3, 4, 5, every card we are able to get one spade. Okay, one spade we are able to get. And same thing, one king from the club, a queen also one we are able to get. Okay, even the jack also we are able to get. Like this till ace, 2 to 10 cards we are getting. Each design we are able to get 13 cards. So just for understanding sake here I am explaining. Even the diamond, okay, here the diamond. So in this case, see, we are able to get 13 card. One is ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, jack and queen and king, which is nothing but your face card. Okay. So like this, everything we are able to get in this total 52 cards, whatever it is there, either it is a red belongs, okay, or black, or based on the design, if you say either it is a spade or club or diamond or art. Okay, so like this we are able to get. Moving forward, so now today is approaching to the probability, very wide area they are using a probability. When approaching is nothing but assigning different experiment we are conducting. So when we are trying to go for studying the experiment or doing experiment, we need to go for some classification approach. So there are different types of approach which is suit for different experiment. Okay, here there are 3 ways of assigning a probability event. The first one is a classical or mathematical or priori probability approach. So this called this one, the first one is a classical and a mathematical and a priori probability. Second one, relative frequency approach, or you can say statistical method or empirical approach method. So sometimes they can ask for the theory questions from the approaches to the probability. So then you have to remember here. And the third one is axiomatic approach, or you can say modern approach, which is most of the area they are using axiomatic approach and modern approach. Moving forward one by one. And what do you mean by the classical or mathematical or priori probability approach? So very simple, when there is a countable numbers or experiment with the help of countable numbers, when we are trying to consider, so which is a classical or mathematical, or you can say priori probability. So here in a random experiment, we are choosing an experiment based on the random samples. So let's S be the sample space. Okay, now the total, for example, if you take a coin, sample space will be always head or tail. Head or tail. This is only one coin we are saying. So S representing a sample space here. Okay, and A is an event. Then the probability of P of A. So why we are writing in the probability functions wise we are writing. So here when we are writing A is an event, okay, the probability of A, because A representing an event from the total samples, so how we are expecting, so here A is an event from the total samples we are expecting. For in case of coin, if you take, so what is the probability of getting a head? There is 1. So you are writing 1 divided by 2. This is just for understanding sake I am writing here to much clarity. The P of A is, N of A is nothing but your favorable result divided by the total samples, okay? Or you can write P of A, you can write M divided by N. M is representing a favorable result or favorable outcomes from the total samples is nothing but your N, okay? So let random experiment have n possible outcome, because n possible outcome means what? So till the result, if you take the dice which is starting from phase number 1 to end with the 6, the total expecting n is here 6. If you take our playing cards, the total outcomes we are getting 52. The n is representing the total possibility. So which are equally likely, either when you are expecting head, tile will not come. When you are expecting a tile, head is not appearing. Mutually exclusive. In the last session, you got in clarity about the equally likely, mutually exclusive and exhaustive. Exhaustive means what? The total samples, the total outcomes from the experiment. Okay. So let M of this outcome be a favorable. Just now I have written here, M is a favorable outcomes or favorable result, you can say. So an event of A. From the event, whatever we are trying to set an event for A or B, okay, so which is, then the probability of A, how you are writing, P of A is equal to M divided by N, because M is a favorable outcomes from the total samples N. Okay, number of favorable outcomes divided by number of exhaustive outcome. Exhaustive outcome means what? The total outcomes expected from the experiment. Okay, so moving forward, so here the limitation of classical definition, you need to what exactly the drawbacks we are facing in the classical approach. So the first one, the outcomes are equally likely, mutually exclusive or exhaustive, because the possibility numbers only we are taking, but large sample size we cannot take, so that is a major limitation. So second one, the possible number of outcomes is n is a finite. You must remember this finite is always countable. That's what from the beginning I told you, when it is a number is countable, or you can say it is a finite. Okay, so moving forward, now second approach. So if there is any drawback from the first approach, of course we are trying to go for the next approach, which is related to relative frequency approach, or you can say statistical method, or you can say empirical method. So in this, alternatively we are choosing, there is a drawback in the first classical approach, so that's what we are trying to go for the next approach called a relative approach. In this approach, an alternative procedures we are following, so known as the statistical method, can be used, assigning probability to event, assigning a probability. For example, in case of coin, when we are saying, so 1 by 2 is an equal result, okay, in case of dice, 1 by 6 is an equal probability assignings, right? So that's what assigning a probability is very, very important. So if the random experiment is repeated under an identical condition, the experiment was repeated, continuously repeated under identical condition. If a coin is a toss n time, number of times we toss, okay, then we are expecting an outcome. So M of this toss result is head. Suppose you are clearly specified, I just want to get head, means the favorable result will be always M is equal to head you are expecting. So from the n number of times, okay. So suppose you are raising a coin, you have already decided to expect it, so head want to appear. But unfortunately tile came, means till head is coming, keep on raising your coin or tossing your coin. Then the proportions of M by N, M is a favorable from the total outcomes, N is a total numbers. So approach, the value P has become a larger. The value P is become a larger. The probability value will be number of time if it is increased. Any probability, the total result will be 1. Okay, which is less than 1, or you can say more than 0 or equal to 0. Okay. In fact, that the limiting value existing cannot be establishing mathematically. The limiting value, because we are finding something restriction till you are getting a head, the keep on the coin is tossing. Okay, so this method of assigning a probability to events in the statistical, this method we are approaching because the first method is something drawback we are finding. So empirical method, it is based on the law of large number. In case of classical approach, the finite numbers we are taking, that limited numbers, but in case of classical or relative frequency method, the large number we are considering here. Moving forward, last one, axiomatic approach, which is nothing but modern approach. So axiomatic, axio means what? Which is a statement. Okay, so some statement, if it is satisfied, so most of the area they are using the axiomatic approach or modern approach. So just for assigning a probability, to assign probability, there are some basic rule called axiom. Axiom means what? There is statement. If the statement is fulfilled or the condition are satisfied. Okay, so based on the statement only we are able to decide, which are specified in the axiomatic definition of probability. Because the statement is applied, the assigning probability based on the statement, of course. Okay, here let A and B be the event of sample space. Yes. Okay, for example, if you try to go for dice, one die if you take, okay, so the total samples will be 1, 2, 3, 4, 5, 6. Okay, in this case, event A is representing, I just want to get hard numbers, 3, 5. Okay, the event B is setting for even numbers, 2, 4, 6. Okay, because from the total samples only we are setting event A is a hard numbers, event B is a even numbers. Okay, here the total sample, I hope you cleared. So let P of A and P of B, okay, are the real number. So from this total samples only we are able to expect even numbers and odd numbers. So now assign to this event, then the probability A is a probability of A dash, the following axioms are satisfied. Because the probability A, what we are decided in advance, the statement if is fulfilled. So the total samples you know, the event of A, event of B also we know, the following axiom or the following statement if is satisfied. What are the statements we moving forward? The statement 1 or axiom 1, P of A is always 0, always greater than 0. Why? Because the result always, for example, if you take the coin head and tail, okay, the probability of getting the total samples will be 1. So head if you are getting 1/2, tail also we are getting 1/2. The probability, or if you are writing fraction 0.5 or 0.5. So we are already assigned this probability value. Okay. So the statement always we are getting more than 0.5. More than 0 means we are getting 0.5 or 1/6 if you try to go. In case of dice, the total samples will be 6. Okay. How we are getting 0.16 we are getting. So which is greater than 0, right? So which is a non-negative condition. The condition number 1, I hope you clear. The probability result always be greater than 0. And second statement, P of S, your total samples will be always equal to 1. Okay, so suppose here 0.5, 0.5, if you get head 0.5, if you get tail 0.5, okay, the both sample, if you add together, total samples will be always 1. The statement you need to satisfy. S is a being of sure event. Sure event, the total samples only, the sure event is completely standing. Now, axiom 3, for any two disjointment event A and B. Okay, so now it is the symbolically plus now if you try to go for a union, what we are doing, probability A, okay, add probability B. Okay, once again I am writing, in the previous slide I have specified, in the previous slide A is a odd number, B is a even number. If you try to go for adding together, what is the result? Which is equivalent to the total sample. Okay, so that's what here A, 1, 2, 3, okay, the total samples when we are writing event A I have set for odd number, and event B which is a even number. When we are writing together, because which the sign is very important, so we are writing 1, 2, 3, 4, 5, 6, the total sample. Okay, so now P of A means what? The event A which is related to odd number. Just for one examples for your understanding, P of A is a M stand for favorable outcomes from the total outcome. Total outcomes we are getting 6. The favorable outcomes for in this case 3 num. 3. How you can say 3? It is a odd number means 1, 3, 5. So the 3 divided by 6 we are getting. So again if you simplify, 1 divided by 2. And the P of A dash means what? A dash means which is not occurring. Okay, which is not occurred. So if you try to subtract, okay, so P of A from the 1, if you try to subtract 1A, which is nothing but P of A dash. Okay, now P of A is a favorable, P of A dash is a unfavorable which is not occurred. So that's what, so P of A dash. How we are writing in the A dash place? So N is a total samples, or in case of die 6, 6 minus favorable 3, okay, so just explaining here, 6 minus M is a favorable outcome is 3 divided by total outcome 6, okay, if you try to simplify, so 3 by 6, again which is simplify 1 by 2, so here P of A is representing M by N and P of A dash representing N minus M divided by N. Again we are trying to go for combine, together we are getting total samples. So here the P of A plus P of A dash, together when we are writing P of A dash A plus, we are writing N by N plus sign. P of A dash, what we are doing, so from the total outcomes we are subtracting favorable divided by N. So when we are getting plus or minus sign, we need to take the LCM. That's what I have written. LCM, common LCM is N. Okay, N cancel. So what is left? M is left. So which sign is there here? Plus sign. Okay, N cancel. Okay, now it is N is a common word. So that's what we are writing, N minus 1. Because here directly LCM we are try to do. So finally which is equivalent to plus and minus M is cancelled. So N divided by N which is equivalent to 1. The statement if is satisfied, then axiomatic statement clear. Keep on watch for next section. Thank you.